Now, checking if a quadratic is a perfect square to begin with. We know how to make it into one with a couple other videos we've done. Now I want to check just to begin with, is it one? So to do that, we need to see, does this C match what we need it to be? So originally we said, when finding the C video, we divide our B term by 2 and then square it. Well, that's just 3 squared, which is 9. Is 13 9? No. So this function, since these don't match, this is not a perfect square. For this to be a perfect square, we would take 9 of those 13 things and we would leave 4 on the outside. This piece can now factor to be x plus 3 squared, and the 4 just stays out. So we can make it a perfect square with pieces of it, but it will have some left over because it wasn't a perfect square to begin with. So for example, x squared minus 10x plus 25, well, C should equal negative 10 divided by 2 squared, or negative 5 squared, which is 25. Hey, they match. Perfect square. Okay. 3x squared plus 12x plus 16. Now let's introduce a third idea. The third idea is that we have to have a 1 as our a, just like with completing the square to see if it is a square, perfect square. We have to have a 1 in this front term. So since it's not a 1, we factor it out. 16 divided by 3 is not a nice number, so we leave it out front, or we leave it as a fraction. So C should be 4 divided by 2 squared, which is 4. Hey, these do not match. Not a perfect square. So one thing we could do is say, okay, well, rather than write 16, we'll put what makes it a perfect square inside. If we can either put the 4 here and completely put plus 16 back on the outside, or we can take pieces of it, just like we did up above here, and break it into 2 pieces. Either creates a perfect square situation. One last example. So for example, if I'm given 2x squared minus 22x plus 12, that front number is not a 1, it's a 2, so it needs to come out. Well, pulling 2 out of 22 makes minus 11x, pulling 2 out of 12 makes plus 6. Well, that tells me that my C should be negative 11 divided by 2 squared. Well, that's just 121 over 4. That doesn't match 6. Therefore, to make this a perfect square, we would say, okay, plus 121 over 4, and on the outside, we'll put plus 12. This trinomial is now a perfect square. So this video doesn't introduce adding a C to complete the square, because we have to add and subtract the same number to cancel it out. I recommend watching that video to see one step that's different. This just shows what the quadratic would have to look like to be a perfect square to begin with. We aren't manipulating it in this video to complete the square, if that makes sense.